Okay, so this is after 4 or 5 days we are meeting, right? Because of sign-ups, you might be very tired. So, moreover, this is lunchtime, just after lunch. So my job is to keep you awake, right? So I hope you can watch this as a movie. Okay, I will show you a few beautiful things. Beauty, after looking at beauty, you will enjoy, right? So anyway, so we were looking at fields. So I started briefly, about fields like football field where we can play football, cricket field where we can play cricket. In mathematics, field means a set of numbers where we can do all the four operations: addition, subtraction, multiplication, division. It's a very simple definition, right? That means for every number a, I can find a number b such that a plus b is equal to 0. 0 is the additive identity, right? So there's an inverse. And all other commutative, associative, those properties will eventually be there if all these four operations are there. Then also there is a, so basically closure is very important. If you take two numbers, add them, you are again in the set, right? Those properties, Similarly, with respect to multiplication, okay, so all the four operations, if you are able to do, like every non-zero element should have an inverse, right? And I think we started with so the well-known examples of the field are field of rational numbers. That's the first example, non-trivial, where there are infinite number of elements. The second one is real numbers, again infinite number of elements. And third one is complex, right? So real and complex are very, very important because I'm going to show you how the beauty of real to complex can be utilized to do something here, which I'm going to show you. But so the question is, by the way, how many infinities are there in a complex plane? Last time I gave you the T time problem. Any answer yet? Yes. Why? You read it on the internet or you did it on your own? That is a very important thing. If you read it on the internet means you have not learned anything. So first answer whether you, yeah, so you looked at the internet. You see, internet, but you can find the answer on the internet, but you cannot find the beauty on the internet, right? So why it is one? I mean, that is a very, very important thing. I should tell you the answer. Think very, very naively, so real line is what? It's a line. One side there is a minus infinity, other side there is a plus infinity, right? So in case of complex plane, we have a plane, right? Now, very loose terms, we say that we can fold the plane into a sphere. Okay, when we fold the plane into a sphere, there will be only one tip point at the top which works as an infinity. So single point at infinity. Now, when I say fold, that means mathematically I'm able to find one-to-one and on-to function from each point on the complex plane to a point on the sphere. See, mathematics is coming very naturally. When I see fold means there is a one-to-one and on-to function. So if you give me a point on complex plane, I will give you a point on the sphere, right? So this kind of beauty. Did you observe this beauty on the internet? So, you need to think in that sense. That's why I'm saying that, in this class, you should get a habit of drinking coffee or tea so that you can actually analyze the beauty, right? On internet, you will not find that beauty, right? So you think on your own, which is missing, right? So take a cup of tea, it's a very nice garden, sit down and think. That is very, very important. Okay. So that's why there is single point of infinity in the complex plane. Okay. Anyway, so that was something which I know that you were not aware of. So we were looking at, so we have, so I gave you an idea of three fields, right? And I think you know that there are equations. For example, from real to complex, there was the equation x squared plus 1 is equal to 0. Because we could not find a root of x squared plus 1 is equal to 0 on the real line So we extended the domain and we went into the complex plane. So the question is, do I need to extend it further? Are there equations with coefficients in the complex numbers that I cannot find a root? Any idea? अरे IIT JEE का एग्जाम तो पढ़ा होगा, कोचिंग कौन सी पढ़ी थी? They have not taught anything. That is a problem, right? Do I need to extend complex plane? Can you find an equation which has no root in the complex? Which one? X square plus x plus 1. No, so this equation has no root on the complex plane? Yeah. Basically, there is some beauty involved with the complex plane. You see, you need to look at the beauty. Beauty is, no matter which equation you take, with coefficients real or complex, you will be able to find a root in the complex plane. That's why complex plane, the field of complex numbers, is also known as splitting field. Splitting field means you take a polynomial with coefficients real or complex, it will split into factors. So you'll be able to find the roots. Okay. That is the beauty thing, beauty content of this, right? The complex plane. By the way, despite of, we know that, so our job is done, like we are able to solve the equations over complex plane, that is fine. But still, mathematicians are mathematicians, so they want to find more beauty. So what they do, even the equation is not there, they still went into higher dimensions and constructed what is known as hypercomplex numbers. Okay? Or Kashi numbers, so some other different kind of things. And some of these things are having applications in mobile. Okay, so whenever there is a beauty, it will have applications also, beautiful applications, right? So basically, there are different kind of constructions, but I think, anyway, I don't have to talk about those things probably, that this is all is needed in your calculus course, but anyway, my job is to talk about discrete things, right? So now when we go to the discrete things, so the first thing is that if I want to construct a field with finite number of elements, the first case is 2. The first field is 2, Z2, you saw that last time. We made two tables with respect to addition and multiplication, and the operation was modulo operation. What is modulo operation? To take two numbers, add them, and divide by 2 and look at the possible remainders, right? And that is how you can set the addition. Similarly, you can do the multiplication, right? So addition and multiplication modulo 2. So Z2 is a field. Z2 is the smallest field in this world, right? It's a beautiful thing. That's why your computer is based on Z2, all binary. So you see, each thing has a beauty, right? So the beauty is that it was the smallest field. So something useful can be built out of it, right? And that's why computers are basically binary. So that is one thing. So from Z2, we can go to Z3. You saw that integer modulo 3 is also a field. So we have an example of integer modulo 2, which is, so you saw Z2 integer modulo 2, which was 0, 1, operations was plus 2, dot 2. We have Z3, you saw Z3, 0, 1, 2, plus 3, dot 3. What about Z4? Is it a field? Not a field. Why? Because not every element has an inverse, because 2 into 2 is equal to 0, right? 2 into 2 is equal to 0, but 2 is not equal to 0. So go and tell your, do you have a small kid in your house? So tell them 2 into 2 is possible. There is a possibility that it could be 0, right? Show them the beauty, they will like it. Anyway, so the question is, how do we construct field with 4 number of elements? Any idea? So he is saying that try, I think last time I told you that if you want to construct a field with 4 number of elements, 2 elements you take 0 and 1, and 2 elements alpha and beta, and try to fill those tables such that all the operations, that's a brute force approach. It's fine. I mean, If the problem is small, I think you can solve that problem. But we need a constructive method. And you see, we need to always look at the first principles. What are the first principles? I think you must have heard Elon Musk interview it many times. Whenever there is a difficulty, go to the first principle, and that's how you can solve the problems. So what is the first principle? How do we construct complex from reals? I will look at that analogy here. So we have real numbers, and in order to construct, sorry, I think I should write like this. We have real numbers. In order to construct complex numbers, I found a equation which has no root over reals, right? X squared plus 1 is equal to 0 has no roots over the reals. So I call the root to be I. Just name. So I is the root here of this equation. I square plus 1 is equal to 0. But this root I is not on the real line, but it is on the complex plane. What is I? I, we can write it like the square root of minus 1, right? So here C is nothing but A plus IB such that A and B are reals. And I is a root of this equation. That means I square plus 1 is equal to 0, or I is equal to square root of minus 1. This is known as complex number. So understood this technique? So this is known as first principle. On the reals, we saw which equation has no root, and we extend the domain. Okay? Now in case of finite fields, I have a very well-known example with us. The smallest field is Z2, having 2 number of elements. So can I use Z2 to construct a field with 4 number of elements? Okay? That is a very natural question you can ask and see if we can do that. Okay? So what I am going to do now, look at Z2. Now the first question, I need a degree 2 equation. So there it was x squared plus 1 is equal to 0, right? So here I don't know which equation to take. So I will write a general degree 2 equation anyway, right? So I'm writing it something like this. Ax square plus, ax square plus bx plus c is equal to 0, where a is not equal to 0 and a, b, c belongs to C2. So now this is a beautiful question. Why it is a beautiful question? How will you solve? Can you apply Sridharacharya formula? Now you see you cannot. समझ में आ रहा है? थक गए हो, I know. So that's okay. So ax square plus bx plus c is equal to 0. How will you solve? Any idea? Competitive programming कर रहे हो? So how do you solve? You think you are smart, competitive programmers, people who are not smart, I am telling you. Yes. Try and see. How will you, because it's all over Z2. Things are a bit different now. Simple equation. By the way, I should tell you, similar 4 equations I gave last time in the quiz with open Google, and none of your batchmate was able to solve. Still they are searching for solutions on the internet. So that's a beautiful thing. Yes. Yeah, A will be 1, fine. So basically, that's a good observation, because A is not equal to 0. So since ABC has 2 values, 0 or 1, we are left with x squared plus bx plus c. So now there are only 4 equations, because B and C can take 2 values, 0 or 1. So I can write down all the 4 equations and see what happens, right? So this is a discrete mathematics, so everything is discrete. But the good thing is about discrete, you can touch the beauty. But on the calculus, you are not able to touch. Here you can touch and feel. That is a beautiful thing, right? So you can see everything. Since A is not equal to 0, the equation will be x square plus dx plus c is equal to 0. So my job is to find an equation which has no root over z2, because that's the objective, right? I need to find an equation just like in reals. We have the equation x squared plus 1 is equal to 0, which has no root on the reals. I am looking at the field z2 and I'm trying to find an equation which has no root on the z2. So I'm going to write all the 4 equations. So you will really enjoy this. You see the beautiful things here. Anyway, so the first thing is that first equation, x square plus 1 is equal to 0. Second equation, x square is equal to 0. Third equation, x square plus x plus 1 is equal to 0. Fourth equation, huh? X plus 1 is equal to 0. Huh? Which one? Very good. Oh. X square plus x is equal to 0. Fine, we have 4 equations. Now which one is going to work? Let us check one by one. First one, x square plus 1 is equal to 0. Whether this equation has a root in the ground field? It has. X is equal to 0. अगर हम plug करेंगे तो क्या मिलेगा? 0 is not a root. Z2 has 2 elements, 0 and 1. Now I try the second one, x equal to 1. 1 plus 1 is 0. It's modulo 2, right? So 1 is a root here. So this equation is not going to work. Right? ये तो बेकार हो गई. What about this? X equal to 0 is a root. ये भी बेकार हो गई. We can strike it off. What about this one? X equal to 0 is a root here also. ये भी बेकार हो गई. What is left? X square plus x plus 1 is equal to 0. And now I want to check whether this has any root here or not. If I put x equal to 0, what will happen? Not a root. X equal to 1, 1 square plus 1 plus 1 is 1, modulo 2. So 1, right? So that means it is not a root. So this is the beautiful equation, which it can build everything, right? Just like that x squared plus 1 over reals we have an equation. Here we have the equation x squared plus x plus 1 is equal to 0, right? So at least we found the equation. Okay, so let us go ahead and so now how do I? So from Z2, elements were 0 and 1, and I found the equation x squared plus x plus 1 is equal to 0. And I'm going to construct a field with 4 number of elements. This notation is no, GF means Galois field. Évariste Galois, who actually discovered these theories in very, very young age, right? So I'm writing it as GF4, Galois field with 4 number of elements, right? Okay, so this is nothing but, remember in the complex plane what we have done? A plus IB. Here I'll call it A plus alpha B, such that A and B are in Z2. And alpha is root of this equation, alpha square plus alpha plus 1 is equal to 0. Right? Perfect analogy. There it was I square plus 1 is equal to 0. Here I am calling alpha. Alpha is root of this equation. Alpha square plus alpha plus 1 is equal to 0. Now can I build a field with 4 number of elements? That's the question. Using this, let us try. Now first time you will feel the beauty, right? And you can touch, you see that, how it works. First of all, you can see that A and B can take 2 values, 0 or 1. How many possibilities? 4. I can write down all the 4 values here. 0. When A and B are 0, then 1, then alpha and 1 plus alpha. 4 equations, 4 elements, right? But I can more simplify it. 0, 1, alpha. And see, you see from here, 1 plus alpha is the same thing as minus alpha square, which is same thing as alpha square. Why? Because 1 is same thing as minus 1. We are on ground field, Z2. So the coefficients in this one, A and B, are always over Z2. So whenever we are doing any operation, we need to worry about the Z2 operations, right? So that means minus alpha square is same thing as alpha square, because minus 1 is same thing as plus 1 modulo 2 over Z2. See the first beauty? So basically 1 plus alpha is equal to alpha square, right? Not only that, if I say that, what is the value of alpha cube here? Alpha cube is alpha into alpha square. Do you agree? Now this is nothing but alpha. Alpha square is nothing but 1 plus alpha. But this is nothing but alpha plus alpha square. But alpha plus alpha square from this equation is minus 1, which is same thing as plus 1. So alpha cube is equal to 1. See the beauty? Now, another beautiful thing, you observe this, that alpha is the root of this. Over reals, this equation, alpha is something like root of unity. Remember? Here also it is root of unity, but not over reals. What is the difference between both of them? Here it is alpha, there it is called as omega. So what is the difference? Yeah, so this is our finite business, that is our infinite business, right? Both are different, though both are called as root of unity. This is also root of unity. Alpha cube is equal to 1, right? There also it is called as root of unity. Because remember, omega has, some complex number, right? Plus minus something, whatever, I don't remember the value, right? So you can find. Here, that is not the case, because you don't know how to solve that x cube, ax square plus bx plus c is equal to 0. That's a simple equation, right? Got it? Now, I want to check these 4 elements, which I have written as 0, 1, alpha, alpha square. Are they forming a field? We can check that. But before that, I should also tell you, there are these, so 0, 1, alpha, 1 plus alpha, this representation is known as polynomial representation, means everything is a polynomial, right? And the other representation, 0, 1, alpha, alpha square is power notation, power of alpha, right? So these 2 things are important. Then you can also develop the third representation, which, because this will be something like 0, 0, because A and B are 0. 1 we can get, how we can get 1? 1, 0, right? Then alpha you will get 0, 1 and 1, 1. So there are bits representation as well. Every element of the finite field, there are 3 representations of this, right? First one, polynomial representation, like 0, 1, alpha, 1 plus alpha. Second one, power representation, 0, 1, alpha, alpha square. Third one, bit representation. Got it? Now, the question is it going to work? So I'll show you why bit representation is very, very important. Okay. And actually your packets, you must have heard about bytes, byte string. Byte means basically 8 bits. 8 bits mean 2 raised to power 8. So actually you are working with a field with 256 number of elements. So each byte is a packet. So each packet is from that field only. Okay. So each packet you can represent as a bits, 8 bits, or a polynomial, or a power of alpha. Okay. There is a need, there is a real application. All your internet ki duniya ye tum karte ho na, WhatsApp, all that blah blah, Facebook and so on, all based on these fields. So very, very basic thing, right? Because we can do all the operations, we can actually play with the things, right? So now I will let us check whether it is going to form a field or not. So I'm going to make the table now. So I'm going to make addition table first. 0, 1, alpha, alpha square, 0, 1, alpha, alpha square, and multiplication table, 0, 1, alpha, alpha square, 0, 1, alpha, alpha square. 0 plus 0 is 0, 0 plus 1 is 1. 0 plus alpha is how much? Alpha. 0 plus alpha square. 1 plus 0, 1. 1 plus 1, 0. 1 plus alpha. 1 plus alpha is equal to alpha square from that equation, right? And 1 plus alpha square is alpha. Alpha. Alpha plus 1 is alpha square. Alpha plus alpha is how much? 2 alpha. Coefficient is 2. Modulo 2 will be 0. So this is 0. And then alpha plus alpha square is 1. Alpha square plus 1 is alpha. Alpha square plus alpha is 1. Alpha square plus alpha square, 2 alpha square, which is 0. Got it? Right? Now we can complete this part. 0, 0, 0, 0, 0, 0, 0. 1 into 1 is 1. 1 into alpha is 1 into alpha square is alpha square. Alpha square. Alpha into alpha square is alpha cube, which is 1. Alpha square into alpha is alpha cube, which is 1. Alpha raised to power 4 is what? Alpha. Now our job is, as in the previous class, we used to check additive identity and multiplicative identity and see whether it is matching. Right. So let us do the same thing here. I'm encircling 0 here. This 0, this 0, this 0, this 0. So 0 plus 0 is 0. So 0 is self-invertive, right? Then what is next? 1 plus 1 is equal to 0. So 1 is self-invertive. Alpha plus alpha is equal to 0. Alpha is self-invertive. Alpha square plus alpha square is equal to 0. So alpha square, each element has its own inverse with respect to addition, right? So we can play with the addition, everything. Now we worry about the multiplicative identity. So 1, 1, and 1. So 1 into 1 is 1. Then alpha into alpha square is equal to 1. Right, or same thing as alpha square into alpha is equal to 1. So basically 1 is self-invertive and alpha square are inverses of each other. So this is a field, 4 number of elements. Don't you think it's a beautiful thing? So first non-trivial example, and you found a way to construct it, right? Field with 4 number of elements. Fine. So I've shown you how to construct field with 2 number of elements, Z2, integer modulo 2, Z3, integer modulo 3, Z4, we tried, but we failed. It is not a field, it is a ring. Then we go to GF4, and we are able to do it. What about Z5? Will it be a field? You can, by making a table, you can see that yes, it is a field. What about Z6? Integer modulo 6. Integer modulo 6, there is a problem because 2 into 3 is equal to 0, modulo 6, but none of them is 0. So it is not a field. So Z7, it is a field. You try some of these examples and then you observe that integer modulo n is a field if and only if n is a prime number. Integer modulo n is a field if and only if n is a prime number. Why is that? Actually, it requires you to take a couple of coffee or tea to observe that if you look at integer modulo, so I am showing you, look at Z3. Z3 means every element has an inverse, right? Forget about 0. So we know that 1 and 3, or everything has inverse. So question that you can ask really, what is the condition for a element A in Zn modulo n when it will be having an inverse? Right? Don't you think this is a natural question to look at? If A belongs to Zn, what condition is there on A such that A has an inverse? Can you find this simple, nice formula? It will require maybe 2 cups of coffee or so, and you will be able to find out. So you try. So how do you approach this problem? Try for Z2, Z3, and see. Observe the pattern. Z4 you see, because Z4 you see, 2 does not have an inverse, but 1 and 3 has an inverse. So something must be important about 1 and 3, why they have inverse. So I'm asking you to find a formula. Right? What is the condition on A when A belongs to integer modulo n when it has a inverse? Any question? This is your T-type problem, right? गूगल पे सर्च करोगे तो मिल जाएगा आंसर, बट you will not see the beauty. You do it and you observe the beauty, right? It's better to observe the beauty by yourself rather than asking someone else, right? So that is a thing, right? So that's about 4. So the question is, the next one is 5 is solved, right? We know that integer model of 5 is a field. What about 6? Can we construct a field with 6 number of elements? So again, see, I'm always thinking like I don't know anything and I have to approach this problem. Let me give you a shortcut or a thinking. I know this thinking is wrong. You need to find out and tell me what is wrong. I said that what I can do for constructing field with 6 number of elements is the following. Z2 cross Z3, A comma B, such that A belongs to Z2 and B belongs to Z3. So now what? Looks like there are 6 elements. Can I make a table and do something? Right. And see if you can do something. So for doing this, you require a cup of coffee and nice evening. Try to think, right? Will this be a field? Can you make this as a field? You will observe that certain elements in this set will not have an inverse. Which one? Why? जब तक करोगे नहीं तब तक beauty you cannot feel, right? Okay, any question at this point? Yes, any question at the back? So actually integer modulo 6 is not a field, but not only that, we cannot construct a field with 6 number of elements. And the reason you can intuitively think like that, for in the case of field with 4 number of elements, we looked at a polynomial of degree 2 at the ground field, which was 2. So 2 raised to the degree of the polynomial, 2 square, gave you 4 elements. So essentially, if I have to construct a field with certain number of elements, it has to be a prime power with this technique. Okay, it means if there is a field with q number of elements, then q has to be a prime power. Then only you can construct a field. So I think it will be clear if we take few more examples. Now we go to the next one. And next one is, okay, so we know that n is equal to 2, there is a field Z2, n is equal to 3, Z3, n is equal to 4, GF4 is a field, 5, Z5, 6, no field at all, 7, integer modulo 7, yes. So essentially Zn is a field if and only if n is a prime number. Okay. So if it is a prime, you can observe the pattern first. How will you prove it? It requires cup of coffees, right, to prove it. Right. So we'll come to those things later on, by the way. So I wanted to show you. So the next case is n is equal to 8. 8 is a power of 2. Looks like that technique that we tried can work. So let us do that. So that means because this power is 3 here, I will be looking for a degree 3 polynomial over Z2 and see if we can construct a field, right? Same analogy. We are not doing any magic. This is how the world works. You look at something, similarly, can I do something here? You try, it works, it may not work, right? So I want to construct field with 8 number of elements. Very good. So I'm looking at the integer modulo 2 and the equation is ax cube plus bx square plus cx plus d is equal to 0. Where a is not equal to 0 A, B, C, D belongs to Z2, right? So again, वो Nike में होता है ना, just do it. So now tell me which equation is going to work. At least I would expect that much. Which equation is going to work, right? What you need to do? How many equations will be there first of all? 8 equations, because A is not equal to 0. So the equation will be x cube plus bx square plus cx plus d. Right? B has 2 values, C has 2 values, D has 2 values. So I can write down all 8 equations and tell me which one is going to work. Maybe I will also write so that you can tell me which one is the correct answer. So the equation that we are left with is x cube plus bx square plus cx plus d is equal to 0. X cube plus bx square plus cx plus d is equal to 0. Okay. So the question is, what are these equations? First case, x cube is equal to 0. Second case, x cube plus x square plus x plus 1 is equal to 0. Next, can you tell me some more equations? X cube plus x square is equal to 0. Fourth one, x cube plus x square plus x is equal to 0. Then x cube plus 1 is equal to 0. Then x cube plus x is equal to 0. Then x cube plus x plus 1 is equal to 0. Another one, x cube plus very good. Now all the 8 equations are there. Which one is going to work? The first one, is it going to work? X equal to 0 is a root. Forget about it. What about this? No, because x equal to 1 is a root here. 1 plus 1 plus 1 plus 1 modulo 2 is 0. So this is not going to work. X equal to 0 is a root. You can always see that. Here, x equal to 0 is a root. This is also not going to work. Oh no, so x cube plus x square plus x, yeah. 0. This is not going to work. What about this? Not going to work. What about this? No. What about this? Yes. So x cube plus x plus 1. So if you plug in x equal to 0, it's not a root. X equal to 1, it is not a root. So this is a equation. Check the next one. Same thing. Bingo, we got 2 equations. अब तो और प्रॉब्लम हो गई, कौन सी ले? Any idea? So there are 2 equations we found. X cube plus x plus 1 is equal to 0 and x cube plus x square plus 1 is equal to 0. कौन सी इक्वेशन तुमको अच्छी लग रही है?
सेकंड वाली.
सेकंड वाली. तो तुम वो सेकंड वाली लेना है, ठीक है? जिसको जो अच्छी लगे वो वैसे शुरू करे, ठीक है? जिसको पहली वाली अच्छी लगे वो पहली वाली ले लो, जिसको सेकंड वाली अच्छी लगे वो सेकंड वाली ले लो. So take the equation and try to build the field. So I can tell you the general method of construction. So what I can do here is the following. Alpha is a root of one of those equations. I mean, you have to take one at a time, right? Whichever equation you are taking. where alpha is a root of either you take this equation or you take this equation. 1. So this time the way method is a plus b alpha plus c alpha square. See? Earlier it was a plus b alpha because we needed 2. So we सोचा क्या करें एक alpha square का term add कर देते हैं, right? Now we have ABC. A, B, C each has 2 choices, so we will be having 8 elements. वो तो कोई problem नहीं है, right? But now we check. So the first question I need to answer, which power of alpha is 1? Oh, who can tell me this? So remember last time it was alpha cube is equal to 1. Which power of alpha will be 1 here this time? Can you find it out? Take your own equation, whichever you like, right? Either you take the 7th number equation or you take the 8th number equation and tell me which one is going to work. What is the power of alpha which will be 1? So यहाँ पे actually क्या होता है ना? How do you work? If you have observed the beauty, you can just look at and observe and you will be able to find the power of which power of alpha will be 1. That observation is very, very important. If you really want to be, yes. Huh? Alpha raised to power 7 is equal to 1. Very good. How did you find? Acha, you computed. Which equation you took? The second, no, 7th or 7th, fine. You can try 8th one, what happens there also. So basically the question is, which one to take? First question that we have 2 equations now. Which equation should I take? Answer is anyone, doesn't matter. If you take equation number 7, you will get some beautiful structure, that tables, right? And if you take the second equation number 8, you get some tables. Answers will be different, but beauty will remain the same. So there is a beauty remain the same means there is a mapping which can map one element to the other element. It's kind of rearrangements actually, nothing more than that, right? So this is the real beauty. We are taking 2 different equations, constructing the field with 8 number of elements, and actually those elements are connected to each other, right? Got it? तो ये तो verify करना पड़ेगा जो मैं बोल रहा हूँ. वो relation क्या है? What is the relation which is there between both the constructions? So see, if I tell you, you will not be able to observe the beauty. You have to try and see. Okay? Try and see. Why? So this is also another tea problem for you. Tea or coffee, whatever you like. If you don't like tea or coffee like Ramdev, you can take juice also, right? But if you don't like juice, then what? Plain water. Don't take this carbonated water or soda and everything, right? Some beautiful thing is required, right? To get new mathematics. Are you getting? Any question if you have, then you ask me. See, you ask any question, any confusion, any question that is coming in your mind. अगर कोई क्वेश्चन नहीं है तो सब कुछ समझ में आ रहा है या कुछ भी समझ में नहीं आ रहा है, 2 ही ऑप्शन होते हैं, राइट? The world is, so this is also binary, right? Like binary field, Z2. कोई क्वेश्चन? सोच रहे हो कि क्यों सेम हो सकते हैं? Yeah, so 7 or 8. I think probably I will do it in the class, but I want to defer it for some time so that you think over it. To see, destination is not important. The way, the path is important. So I want you to walk through the path, feel yourself, then you will see the beauty, you will really enjoy it, right? If I should tell you right away, this is the beauty, you will say, oh, I don't know, because you have not traveled that path, right? So it is better you observe on your own. So at least I gave you this idea. Either you take this equation or you take this equation. So try to construct field with 8 number of elements. In the next class, I will actually do this for you. But try to construct a field with 8 number of elements. Either you take this equation or you take this equation. You know that how to, do this, right? Just plug in the values, and as usual, you can see that we have, polynomial representation, and you can write down the power alpha representation. So actually that gives you a hint. Since we know that everything will be a power of alpha, it is very easy for us. You assume, suppose the equation is this. That means alpha cube is equal to alpha plus 1. You compute the value of alpha raised to power 4, some polynomial, alpha raised to power 5, alpha raised to power 6, and you see that alpha raised to power 7 turns out to be 1. So all powers are written. You can write down the values directly. I mean, this is a common sense, right? Just compute the powers of alpha using that equation, and you can write down everything. And you can make the table with respect to addition and multiplication, right? Got it? So this was the field with 8 number of elements. Now what is the next? 9. अब थोड़ा सा कहानी बदल जाएगी, right? 9 means 3 square. The ground field should be C3, integer modulo 3. And equation 3 square should be of degree 2. So you have to write down the equation ax square plus bx plus c is equal to 0, where a is not equal to 0 and a, b, c belongs to Z3, integer modulo 3. How many equations will be? 3 into 3 into 2. Huh? So, Tej bolo. 18. Yeah, 18 equations will be there. Out of those 18s, which is going to work, you need to find it out, right? तो 2 3 4 कप और लगेंगे, हो जाएगा काम. Right. So, okay. So you can try that. Right? But it's a beautiful thing, right? I can summarize a few things here. So these two equations we need to take. So for field with 9 number of elements, I need to look at integer modulo 3. Equation is ax square plus bx plus c is equal to 0. A is not equal to 0. A, B, C belongs to Z3. Right? So you need to tell, I mean, GF9 will be A plus alpha B such that AB belongs to Z3. And what is alpha? Alpha is root of that mystery equation or that beautiful equation which is going to build the field. वो तुम लोग find out कर लोगे, right? Which equation is going to do the job for you, right? जब तक कुछ चीजें छोड़ो नहीं ना, तब तक तुम मजा नहीं आएगा तुमको, right? So you have to observe the beauty, right? So basically, write down all the equations. You know that 18 equations are there. Check. So now this time you will be, rather than 0 and 1, you will be plugging 0, 1 and 2 and see, right, which one is going to work. कुछ चीजें मैं अगले लेक्चर में कवर करूंगा, but you know, first you try, then we will come back. ठीक है? अगर ट्राई नहीं करोगे तो फिर तो ऊपर से चला जाएगा, राइट? See, मैथ को जब तक तुम एंजॉय नहीं करोगे ना, unless you enjoy the beauty of mathematics, you will never be able to. You must be trying competitive programming. I am telling you, competitive programming is nothing. If you have read the book, The Art of Computer Programming by Donald Knuth, your job is done. If you cannot understand Art of Computer Programming by Donald Knuth, that means your foundation is weak, both in mathematics and computer science. You know about that book? I think I can show you. Yeah, this is the book, a couple of volumes. So if you look at volume 1, at the back of it, there is a statement by Bill Gates. He says that if you have read the book, send me your CV and I will hire you. Right? Because you know that if you are able to read this book, you don't require competitive programming, which is useless. If you are in the interview and if you say that you have read this book, the other person will be down. या तो उसने पढ़ा होगा या तो नहीं पढ़ा होगा. अगर बाबू होगा, MBA वाला होगा, there will be a problem. Right? So you see, you can be strong. आंखों में देखते ही आदमी को समझ में आना चाहिए, अरे ये तो डोनाल्ड लुथ की बुक पढ़ के आया है, so we know how it's. And I've seen many such cases actually, right? So volume 1 भी पढ़ लोगे तो it's good. I have tested this. There are many students from your university who has read by the second year they read in one summer about 75-80% book, and they are top people now. Okay, so they successfully started 2 companies. Salesforce customer, they have one of the student has broke. I mean, he got all the customers from Salesforce. The system he built, because if algorithm is not there, you know what to do because you know math. If you don't know math, you rely always on the libraries. Okay, ये library तो है नहीं, अब क्या करें, right? That problem will always be there. So जो competitive programming की अंधी दौड़ है ना, उससे ज़्यादा भला नहीं होने वाला है. बाबू बन सकते हो, लीडर नहीं बनोगे. ठीक है? So your choice is yours. You want to be leader in the commanding position or you want to become babu. 2 options are there. ऐसा नहीं है जिसने अगर ये बुक पढ़ा है, लीडर वाला पाथ चूज किया है, तो ऑब्वियसली कॉम्पिटिटिव प्रोग्रामिंग तो उसका ऐसे ही हो जाता है, राइट? इफ यू दैट काइंड ऑफ लेवल ऑफ डेप्थ you have, right? You don't have to worry about all the other things, right? Anyway, so that is just a minor thing. So you please do read this book. और देखें क्लास में कौन पढ़ लेता है. It must be there on your shelf, right? Art of Computer Programming. Amazon में आज जो है ना फटाफट क्लिक करो. ऐसे लाइब्रेरी में there are a couple of copies, but you can get at least read volume 1, right? And see the level. Your competition यहाँ local नहीं है ना, all over the world. Resources limited है. At your age group, there are how many people in the world? You have to fight with the competition, right? For job and everything. So you have to be the best among them, right? And in order to make you best, you need to read best book. So actually there are certain things which you cannot leave in your BTech program. This is one such book. There are many other books for each subject. I can tell, well, that's a separate story altogether. But I can tell you this book you must read. Otherwise, if you have not read this book, your education is incomplete. So if not read this book, your computer science degree will be incomplete always, right? Or ICT, whatever. Anyway, so that's the thing about this book. I think that's all. अभी आज इतना हो गया. So next time we will see some more beauty. I hope by the time you will enjoy some tea, coffee.